Today, we're going to be talking about forces with levers, an idea called mechanical advantage, and I'm going to be teaching you about 3 classes of levers. So here we have Mr. Bill Nye and Mr. Albert Einstein balanced on this lever. And you can see that Al is a little bit heavier because he's closer to the fulcrum. Okay, Bill's a little bit lighter, he's farther away from the fulcrum. And so far the work that we've been doing with levers has mostly involved trying to get things to balance. But now we're going to think about using levers as a lifting tool. Okay, so gentlemen, I'm going to have you step aside here for a minute. So I'm going to put my trusty Easter Island head on my lever over here. And now I'm going to think about using this lever not as a seesaw that's balancing, but rather as a way of lifting this kind of heavy-ish object. Okay, now the real Easter Island heads on Easter Island are almost unimaginably heavy. This thing is not that heavy, it weighs about 3 pounds, okay? And now if I put my hand over on this side of the lever and I start pushing, I have to push with 3 pounds of effort, 3 pounds of force to lift this 3-pound load, okay? So the weight that we're lifting we call the load. The force that we're using to lift that load we call the effort. If I only push with 1 pound of effort, not enough force. If I push with 2 pounds of effort, still not enough force. I have to push with 3 full pounds of effort to lift this 3-pound weight, this 3-pound load, okay? Now, I could make my job a little bit easier, all right? I could move our Easter Island head closer to the fulcrum and still keep my hand way out here. Now if I do that, that means that it's going to take less effort to lift that load, okay? It's just like when you're on the seesaw, a lighter person over here can balance a heavier person over here if the heavier person's closer to the fulcrum, okay? So now as I push down, I don't have to push down with 3 pounds of force anymore, okay? Where I've got this head positioned right now, I'm only having to push with about 1.5 pounds of force, only half as much effort. But there's a trade-off here, okay? Take a look at this. As I push down on the effort side of this lever, my hand has to move a much greater distance than what the load moves, okay? So if I wanted to raise this load up 1 inch, I would have to push my finger down about 2 inches. I have to move my effort about twice as far as the distance that the load moves, okay? If I want this to go up 2 inches, I'm gonna have to push down 4 inches over here, okay? Now, if I move the load even closer to the fulcrum like this, I get even more of an advantage, more of a mechanical advantage, meaning that it takes even less effort to lift the load. But with every advantage comes a disadvantage. And the disadvantage with simple machines is that if you use less effort, you have to move that effort a longer distance, okay? So watch how little the load moves compared to how much my hand moves over here. You can see that my hand is moving a long distance, but if we look at how high up the load actually moves, he's not gaining all that much height, right? So this is always the trade-off that we have with simple machines. You can use less effort, but you have to move that effort a farther distance, okay? Now, I could go the other way, all right? I could put my Easter Island head way out here, and I could push closer to the fulcrum. Now, with where this is positioned, where my finger's positioned right now, I'm actually gonna have to push with about 6 pounds of effort to lift the load. So it makes it harder to lift. It's actually easier now to just pick this up and lift it. This only takes 3 pounds of effort, but if I put my hand here, it takes about 6 pounds of effort. Now, if I move my finger to about here, it's going to take about 12 pounds of pushing force, 12 pounds of effort to lift this 3-pound load. I can really feel that. That takes a lot of effort. And if I was to move my finger into about here, it would take about 24 pounds of lifting force to lift this same load. That's really hard to do with just my finger. So that's a disadvantage, but with that disadvantage comes an advantage. Check it out. Because if I am willing to push that hard over here, my thumb only has to move a very small distance, but the Easter Island head lifts up much, much farther, okay? Check it out. Watch how little my thumb moves compared to how much height the Easter Island head gains, okay? So again, this is always the trade-off with simple machines. If you want to use less effort, you're going to have to move that effort a farther distance than the load moves. If you're willing to use more effort, you can move your effort a shorter distance, the load moves a longer distance, but you have to push harder, okay? You have to push harder. Now, Suppose, and we'll put Easter Island Head aside here for a minute. Suppose I wanted to use my lever to launch something up into the air, okay? So I'm just going to use this eraser because it's a fairly safe object here. So I could put that on one side, and if I give a good whack on the other end of the lever, I'm hoping that I can get this thing to kind of fly up into the air. All right, let's try it. Not too bad. Let me retrieve my eraser here. Okay, but let's find out. Now, maybe this would work better if I move the eraser closer to the fulcrum. Okay, let's see what happens this time. No. Because when this is close to the fulcrum, my hand over here that was slapping down on the lever moved a long distance. This only moved a very short distance, so it didn't go very fast, all right? But watch if I do the opposite. If I put the eraser way out here at the end, and I hit real close to the fulcrum here. Now I'm gonna have to hit harder because it's gonna take more effort when I push my effort closer to the fulcrum, but my hand's gonna move a shorter distance, the eraser's gonna move a longer distance, and it should allow me to launch it up into the air better. All right, let's see if it works. Yeah, I think that was better than before, all right? So again, this shows us this whole idea of trading force and distance, all right? Now, there are some ways that we could use levers that we haven't looked at yet. I'm going to put Easter Island Head back on here. I should just give this guy a name, like, I don't know, I'll come up with something. Anyway, we're going to put this guy over here, like I did before. This type of a setup is what we call a Class 1 lever, all right? In a Class 1 lever, the fulcrum, the pivot point, is positioned somewhere in between the load and the effort. So you have effort on one side, load on the other side, fulcrum in the middle of a Class 1 lever. All right, now, the load and effort don't have to be the same distances from the fulcrum. Okay, one could be closer, one could be farther away. But as long as the fulcrum is somewhere in between, those two other things, that's what we call a Class 1 lever. Now, you might be surprised to find that you use a lot of Class 1 levers in your everyday life. It's not just seesaws, okay? A pair of scissors is a good example of a Class 1 lever. Now, this is actually a double lever system. Over here we have two lever arms that cross and share the same fulcrum. Over here we have where we apply the effort. Okay, we have our handles. All right, that's where the effort is located. Over here is where we have the load. Now in this case, the load's obviously not something that we're lifting. It's something that we're trying to cut through. It's a resistance that we're trying to overcome. Okay, but we have the effort on one side, load on the other side, fulcrum in the middle, which makes, here I'll turn it over so you can see that little screw where it pivots, fulcrum in the middle, and that makes this a Class 1 lever. Now, these tin snips you can see are similar to scissors. They're also a Class 1 lever, but notice that on the tin snips I have much longer handles and much shorter blades. And this means because my load is close to the fulcrum and my effort is far from the fulcrum, that it gives me the mechanical advantage of using less effort. Okay, this one takes a lot less effort, so I can cut through tin, I can cut through metal and things like that, but look at the disadvantage. The blades move just a very small distance while the handles move a much larger distance. Okay, now with the scissors, where I have shorter handles and longer blades, I have to push harder, but with every snip, I can cut more paper or more fabric. All right, so Class 1 levers. Now, we could set this up in a little bit different way. I'm going to put Mr. Easter Island Head here, who still remains nameless, somewhere a little closer to the fulcrum, and instead of pushing down on this side, I'm going to pull up on this side. This makes what we call a Class 2 lever, In a Class 2 lever, the load is located somewhere in between the effort and the fulcrum. Okay, so again, in a Class 1 lever, the fulcrum is somewhere in between the effort and the load. In a Class 2 lever, the load is somewhere in between the effort and the fulcrum. Now notice that to make the load go up, my effort actually has to pull in the same direction, it has to pull up. Okay, so this is a Class 2 lever. Now in a Class 2 lever, because the load is always closer to the fulcrum, and the effort is always farther from the fulcrum, it always reduces your effort. Okay, this is a type of lever that always makes things easier to lift. Of course, the disadvantage that comes with that is that your effort has to move a greater distance than what your load moves. Okay, farther distance, shorter distance up and down. All right. Here's something that we have in our kitchen. This is a garlic press. So the idea is that you put a clove of garlic in here, and then this little presser goes down into there, and then you squeeze these handles together. Well, this is a class 2 lever. The fulcrum is here where this pivots, the hinge, okay? The load is this pressing device and the clove of garlic that you're trying to press with it, and the effort is at the handles here. So in this lever setup, we've got effort, load, then the fulcrum. So notice that the load is in the middle. This is a class 2 lever, okay? Load in the middle. All right, the third lever class is called a class 52 lever. I'm just kidding, it's called class 3, okay? So in a class 3 lever, the effort is actually in between the load and the fulcrum. So the way that works is, we'll show you with Mr. Easter Island Head once again here, is that I would put him out further from the fulcrum someplace, and then to lift him, I have to put my effort somewhere between the load and the fulcrum, okay? And I lift up, ooh, fulcrum wants to come right up. I'll pin the fulcrum down with my other hand. So when I lift up like this is a class 3 lever. Now in a class 3 lever, you always have to push or pull harder. And that's because the load is always farther away from the fulcrum and the effort is closer to the fulcrum. So this actually right now is probably taking about 6 pounds of effort to lift this load, even though the Easter Island Head only weighs 3 pounds, all right? And that's a disadvantage, but remember that simple machines trade advantages and disadvantages. And the advantage to this is that even though I have to pull harder, the head moves farther than my hand. Okay, so a small movement of my hand creates a large movement of the head. All right, so that's where we get our advantage with this kind of thing. Now, here's an example also from my kitchen of a class 3 lever. These tongs here have a fulcrum at one end. This is where the pivot point happens. The load is over here. It's whatever you happen to be grabbing with this thing, all right? And the effort is where you squeeze the handles, all right? So class 3 lever has the effort in between the fulcrum and the load, all right? Here's another example of a class 3 lever. It's my old raggedy fly swatter here. This thing has seen a bit of action. Now, in this one, the way that you use a fly swatter obviously goes something like this, right? And notice that the fulcrum actually is located in my wrist when I swing this thing and swat at a fly. So the fulcrum is here, the effort is where I hold onto it with my hand, and the load is out here. It's the swatting end of the swatter, right? So fulcrum, effort, load, with the effort in between the fulcrum and the load. Okay, so that's our 3 lever classes. And there's a handy little way to remember this. It's called FLEE 1, 2, 3. FLEE 1, 2, 3. Now I know that FLE isn't actually how you spell like the word flea, like when your dog has fleas, but if you take a look at how this is written, notice that the F goes with 1, and that tells you that when you have a class 1 lever, the fulcrum is somewhere in between. And I like to say somewhere in the middle, as long as you understand that doesn't mean exactly in the middle, okay? So in a class 1 lever, the F, the fulcrum, is in the middle between the load and the effort. So this is a class 1 lever, okay? In FLEE 1, 2, 3, the L and the 2 go together. And that tells you that in a class 2 lever, the load is somewhere in the middle between the effort and the fulcrum, okay? Class 2 lever, 2 goes with L, and the load, L for load, goes in the middle. In a class 3 lever, notice that the E goes with the 3, all right? E goes with 3, and that tells you that the effort is somewhere in the middle between the load and the fulcrum, okay? So, again, pin down that fulcrum. Okay, effort's in the middle, that makes it a class 3 lever. So FLEE 1, 2, 3, fulcrum in the middle of a class 1 lever, load in the middle of a class 2 lever, effort in the middle of a class 3 lever, okay? Last thing today, guys, we've got more animals to name. Paige has sent us a picture of some chicks that recently joined her household, and we're going to put a form out there today, so if you have any ideas for these cute fuzzy little things right here, shoot them our way. I hope you guys have an awesome day, and we'll see you later.